Okay, so today we're going to review how to solve inequalities. And this is the third lesson. You will find this PowerPoint on my homepage. So feel free to look over that or to rewatch this video if you need to. These are all things that you have learned. Some of them are a little more complicated, but the main concepts you have learned. And then we're going to apply what we learned into word problems, real life problems, to see can we write inequality and solve it. There's three things you need to remember, three basic concepts. One, do you flip an inequality symbol? You flip it. You flip the symbol whenever you multiply or divide by a negative. Whenever you multiply or divide by a negative number, you're going to flip the inequality symbol. Okay? All right, so here we go. I'd like you to look at example number one. Example number one, please. This is example number one. You should see that. And I'm going to work it right here. So our goal is to solve this. I'm going to put a line underneath the inequality symbol. And you're going to see that I think it's advantageous to always move the variables to the left-hand side when it comes to graphing our solutions. So I'm going to start by moving the negative 4a to the opposite side. Opposite of positive is negative. 5a minus 4a is 1a. Again, I want to isolate the a, so I'm going to add 3 to the opposite side. 2 plus 3 is 5, and dividing by 1 does not change my answer. Oh, oops, excuse me. Now I need to graph this. What does this look like? So we're going to make very simplistic, very simplistic visual solutions. Okay, so our solution set, you're going to put 5 in the middle. 5 is going to have a circle at 5 because greater than or less than symbols have circles, which means we don't consider this as an actual solution to the inequality. So I have a circle, and then the reason why I suggest you put the variable on the left is when the variable is on the left, think of this as an arrow. This says shade to the right. So I shade to the right, and I shade in the arrow. This represents all the solutions to this inequality. For example, over here is 0. Is 0 part of this solution set? No, it's not shaded. Is 5 part of the solution set? No, it's not shaded. Is 10 part of the solution set? Yes, it's shaded. Okay, fine, please. Example number 2. Example number 2 again. If you find the PowerPoint, you will see the work for it. Okay, find example number 2. Starts with a 7b. If you're feeling pretty confident, as this is review for you, feel free to work ahead with this particular problem. So again, there's more than one way to often do math. I'm going to suggest moving the variables to the left. 7b minus 6b is 1b. I'm going to move the 4 to the opposite side by subtracting. Take 4 away from 13, I'm left with 9, and dividing by 1 does not change it. So b is less than or equal to 9. Put 9 in the middle of your number line. But for this particular problem, because there's a line underneath, that identifies 9 as part of the solution set. And as long as the variable is on the left-hand side, this acts as an arrow. It says shade to the left. So shade everything to the left and shade in that arrow. And that insinuates that the solution set continues to go to the left. It doesn't stop right here. Right now for this class, can you do a thumbs up if you're understanding or a thumbs down, just so I know? Okay? Let's move on right now. Please look at example number 3. Example number 3. Example number 3 looks like this. Our goal is to simplify this problem. Remember, there is more than one way to do this. So I want to get rid of having a fraction. So to do that, I'm going to put parentheses around both sides. Parentheses around both sides. And opposite of dividing by 5 is multiplying by 5. So yes, we don't see the 5s anymore and we think they disappear, but in reality they turn into a 1. It doesn't impact the problem anymore on the right-hand side. 5 times negative 3c is a negative 15c. Again, my suggestion is to move the variables to the left-hand side. I'm going to add 4c to both the left and right. And now to isolate the c, I'm going to divide by negative 11. Remember, whenever you multiply or divide by a negative, we're going to flip the inequality symbol. So I'm putting negative 2 in the middle of my number line. For this particular problem, I'm going to have a closed circle, which it identifies negative 2 as part of the solution set. As long as the variable is on the left, we think of this as an arrow. It says shade to the right and shade in the arrow. Do me a favor right now. You have 3 responses to my next question. Thumbs up is yes, thumbs down is no, in the middle is I don't know. Turn to the person across from you. Once again, thumbs up yes, thumbs down no, thumbs in the middle is I don't know. Here's the question. You ready? Negative 15 is a part of the solution set. Tell your partner, not me, based on thumbs up, thumbs down, thumbs in the middle. Negative 15 is a part of the solution set. If you're confused, you're like, yes, negative 15 is part of the solution set. No, it's not, or I don't know. Negative 15 is way over here, is a part of the solution set. Okay, what about negative 2? Thumbs up, thumbs down, or in the middle? Should be thumbs up, yes. What about 0? Yes. Okay. Please find example number 4. Again, if you look at the PowerPoint, you will see the work shown, and you can look at that as well. So your example 4 looks like this. Here's the mistake I've made. I will correct for next year. I believe this is a different variable, so change it so that we have D for both variables of example number 4. And again, if you're feeling confident, feel free to work ahead, but I will tell you this problem is just a little more work. I don't want to work with fractions, so I'm going to take what's being divided by, I'm going to multiply both sides by negative 4. But remember, this is where there's a little bit of confusion. We just multiplied by a negative, which means I need to flip the inequality symbol. Now I'm going to move the d's to the left-hand side, so I'm going to add 5d to both sides. And I want to isolate the d by dividing by the quantity that's stuck with it. So I'm going to divide by negative 27. Again, we just divided this time instead of multiplying by a negative. When you divide by a negative, you need to flip the inequality symbol. And I'm going to reduce that fraction down to negative 1/3. Negative 1/3 in the middle. We have an open circle identifying negative 1/3 as not being part of the solution set. As long as the variable is on the left-hand side, I think of this as an arrow saying which way to shade. I'm going to shade to the right. Now, most students get a little more confused with fractions. Okay, so negative 3. Is negative 3 part of the solution set? Thumbs up to your partner, thumbs down, or thumbs in the middle? Here's negative 3, yes or no? Okay, tough one. Negative 1, is it part of the solution set? Thumbs up, thumbs down, or in the middle? Negative 1. Well, you may be confused where is negative 1. Negative 1 is still to the left of the circle. What about negative 1/3? Thumbs down, not part of the solution set. What about 0? Should be thumbs up, part of the solution set. Once again, the work is done here if you want to look at the PowerPoint for every single step. And we're going to move on right now to example number 5. Example number 5. Now, example number 5 is going to remind you of what we did last week. Let's simplify this again by getting rid of the fractions. So put a little line underneath the 2 and the 3 that lie in the denominator. What is the smallest number that both 2 and 3 divide into? So parentheses 6, parentheses 6. Okay, that's our first step. Now I'm going to come down here and show my work. 6 divided by 2. Watch again. 6 divided by 2 is 3. And I haven't done anything with the numerator, so I write it down. 6 divided by 3 is 2. Haven't done anything with the numerator, and I write it down. I'm going to distribute the 3 and distribute the 2. Then I'm going to move the variables to the left-hand side. And there was quite a bit of confusion about this part. Most students thought in a previous hour that we would flip the symbol because your final answer is negative. But the question I asked is, did we divide by negative? We did not, so we don't flip the symbol. Here's my answer. Open circle. As long as the variable's on the left, I shade to the right and shade in the arrow, which identifies the solution set as continuing to go to the right. Can you do me a favor right now? Raise one hand on 1 through 5, 5 being that you fully understand, 1 being the lowest. 1 through 5, what's your level of understanding of this? Okay, here we go. Find please example number 6. Example number 6. Example number 6 looks very similar. Remember, it is important for us to practice speed, so you're prepared for checkpoint quizzes, for unit exams, and most importantly, for standardized tests like the ACT and SAT. So if you don't get this done in the time I provide you, don't worry. If you get it wrong, that's okay as well. Let's see if you can do this problem in 40 seconds. I'm going to do it as well. Ready? Get set, begin. If you get stuck, feel free to look up what I'm doing. One through 5 right now, even if you're not done right now. 1 through 5. If time was not a factor, your level of understanding for this particular problem right now, practice it on your own. I need everybody to give me a 1 through 5, not just sitting there and staring. Okay. Right, let's go on to number 7A. I did make a mistake with 7B, so you'll have to look up here when we get to that point, but let's start with 7A. This is an 8th grade concept, sometimes a little bit of 9th grade, but it is often difficult for students. We're going to translate this sentence into an equation. Remember, whenever you see the word less than or more than, the word then means we need to flip the order. We need to flip the order. Less means to subtract. Product means to multiply. Is greater than is our inequality symbol. This is greater than. So I'm going to start with, okay, 9 less than. So I put a subtraction sign. But instead of the 9 going in front, like I read it from left to right, because I see the word then, 9 is going to go in back. I'm going to flip the order. What went in front when I read it now goes in back. And what goes directly after less than will go in front. The product of 2 and a number, the product of 2 and a number is 2 times the variable. 9 less than 2, the product of 2 and a number, is greater than 31. 15 seconds, please solve. Going on to example B, this is where you're going to see a difference in the back of your first page. You do not have this. I understand that I just made a mistake and put the same problem for you twice. So forget about doing the problem that you're seeing for 7B. Please do this problem with me. The quotient of 4 times the number n7 is at least 8. So the most difficult part of this problem is the word at least. Let's circle the word at least. Let's pretend you applied for a job and you met with the manager and the manager says, I'm going to hire you and I promise you you'll make at least $9 an hour. Does that mean you're going to make $8 an hour? Not a chance. If he says you're going to make at least $9 an hour. Does that mean you can make $9 an hour? Yes, that's the minimum. Does it mean you can make 10 or 11? Yes. It's 9 would be the minimum and anything above that would be acceptable according to a statement if you'd make at least $9 an hour. So when you see the word at least, it means that portion needs to be greater than or equal to. This portion needs to be greater than or equal to 8 in this instance. So the quotient, I'm going to divide 4 times the number, so 4x, and I'm going to divide it by 7. Whatever you see comes first as the numerator, and second, separated by the word and, is the denominator. 4 times a number and 7. Please solve right now for x. So x is greater than or equal to 14. First I multiply it by 7 and then divide it by 4. Find C, please. 7C. Can you please check for me? Is this your 7C? It is. Okay. 7C is the most difficult out of all of them. So this is where it gets difficult. It says I want to take 1/4. So let's write down 1/4. And please draw an arrow to the word of. Of means multiply. Of means to multiply. So I want to take 1/4 and I want to multiply it times the sum of 2 things. So I want to multiply it times the quantity of the sum means add, of 2 things. What are the 2 things? 3 times the number, 3x, 3n, whatever you want your variable to be, and 12. 1/4 times, 1/4 of times the quantity, the sum of 3 times the number and 12. And that portion has to be greater than the next portion. The next portion says 1/5 the sum of, again I'm multiplying by a quantity of that number and 10. 45 seconds. Go ahead and solve, please. Refer back to some of the previous examples we need if you need a little bit of help on how to eliminate the fractions. divided by 4 is 5. 5 times 1 is 5. 20 divided by 5 is 4. 4 times 1 is 4. Okay, distribute the 5. Distribute the 4. I'm going to come over here. I have 11x plus 60 is greater than 40. Subtract 60 to the opposite side to isolate the 11x. Divide by 11. 11 is not negative, so I'm not going to flip the inequality symbols. Does anybody have questions about this particular problem? Does anybody need me to leave it up here any longer? Okay, let me know when you're done. Okay, let's move on right now to number 8. Please find number 8. Please read number 8 to yourself. Number 8 is a little bit tricky. I'm going to ask different students to explain to me what they know about the word problem. I'll give you time to read it. All right, so let's go with Andrea. Andrea, raise your hand. Where is Andrea? Andrea, what do you know about this problem? What are you trying to find, actually? Tell me that.
How many candles you have to sell to get?
This is the unknown. So let's put down a little c, guys, underneath this. You could have any variable you want. Let's put a little c. Let's go with Miguel. Where's Miguel? Miguel, what is the goal? We want to find out how many candles, but what do we also need to know? How many candles in order to what? More than 100. This is the key, everybody. More than 100. So we're working with inequalities. Whatever we have has to be greater than $100. It cannot be equal to it. Jesus Contreras, where are you? Jesus. Jesus, what do we know? What else? You get 5% for every candle that you sell. Okay? What else? What other information do we know, Vasti? So automatically, every student is going to get $20 from the company for this fundraiser. And then, like Miguel said, they're going to make an additional 5%. Now, when we put this into a word problem, we're going to change 5% into a decimal. So they make 5% of every candle. And what the other fact we know is we know that on average, every purchase is $16 on average. And we want to know how many candles. How many candles does Karen need to sell in order for her to profit for this contribution for a fundraiser more than 100? Okay, I'd like you to solve right now for C. I'll do it at the same time. Go ahead. Can somebody help me out? Take 0.05 times 16 for me, please. You have a calculator in front of you. 0.05 times 16.
28.
What is it? 48?
0.8.
Oh, 0.8. Gotcha. this mean? It means candles, because that's what my CO is. Candles are greater than 100. So in order, you're going to have to write a sentence here. In order for Karen to be able to contribute more than $100, she must sell more than 100 candles. You need to write it as a sentence. Make sense of your answer. In order for Karen to contribute more than $100 to this fundraiser, she must sell more than 100 candles. Ms. Kaufman is taking her history class on a field trip to a museum, and the school has provided her with $572 to spend on the trip. There are 52 students that will go to the museum, and the museum charges $5 per student, and Ms. Kaufman gets in for free. If the students will have slices of pizza for lunch that cost $2 each. Notice that it does not say about Ms. Kaufman eating pizza. If the students will have slices of pizza for lunch that cost $2 each, how many slices can each student have, assuming that Ms. Kaufman is bringing her own lunch? Okay, on your own, whatever math doesn't matter to me. Let's see if you can work through this using some common sense and getting an answer. I'm going to give you on your own a minute and a half. Begin. All right, so check with the person next to you and see what they have for an answer. What's 52 times 5? 260? 52 times 5 is 260? Okay. So out of this budget, out of a budget of $572, $260 must go towards tickets to get into the museum. Can you please take 572 and subtract 260 for me? What do you have for an answer? 312? Okay, the remaining money is going to go towards pizza. Now, how much does it cost per slice? A couple different ways we could do this. What is it per slice? Okay, please take 312 and divide it by 2. It tells me how many slices I can have. What's 312 and divided by 2? 156. Okay, so I have 156 slices, and I need to be fair here. You know how students, how they like things fair. So I need to divide that equally among 52 students. So take 156 and please divide it by 52. What is your answer? 3. So assuming that Ms. Kaufman gets into the museum as stated for free and that she brings her own lunch, again stated in the problem, each student will receive 3 slices of pizza.